Okay, so I'm going to go over 3 examples of how to use the rule of multiplication when looking for the probability of 2 traits occurring in an offspring. Okay, so let's use eye color and hair color and freckles as our example. So let's pretend a heterozygous brown-haired person with no freckles is crossed with a blonde-haired, no freckle person. So here are their genotypes. And the question is, what is the probability of them having an offspring with brown hair and no freckles? So if I look at my little key over on the left, I see that brown hair is dominant, and I see that no freckles is the recessive phenotype. So what we're going to do first is we're going to focus only on hair color. So if I look at the 2 parents, I have a brown-haired person who's heterozygous and a blonde-haired person, homozygous recessive. And I look at what's the probability of them having an offspring with brown hair. And I find that it's a 1/2 or a 50% chance. Now let's go ahead and look at the probability of this couple having a child with no freckles. Well, if I have 2 homozygous recessive individuals, 100% of their offspring are going to have no freckles. So that is a 100% probability. So the way we do this, though, what is the chance of them having an offspring with brown hair and no freckles is you're going to multiply these 2 fractions. And so we would do 1 times 1 is 1, and 2 times 1 is 2. So there's a 1/2 chance or 1/2 probability that they will have a child with brown hair and no freckles. Okay, but let's go ahead and see what would happen if it wasn't 2 homozygous recessive individuals for freckles, right? So here we have a heterozygous brown-haired person crossed with a blonde-haired person. And again, the heterozygous brown-haired person has no freckles, but now the blonde-haired person is heterozygous. Sorry, I made that more complicated than it needed to be. Anyway, what's the probability of them having an offspring with brown hair and no freckles? Okay, so again, we're going to look at just hair color, and it's still the same, 1/2, a 50% chance. Now, though, the parents have different genotypes for freckles. So we do the Punnett square, and we find it's a 1/2 chance that they're going to have an offspring with freckles. So what's the probability or the likelihood of an offspring being born with both brown hair and freckles is we're going to multiply these fractions. So when you multiply 1/2 times 1/2, it's going to be 1/4. So an easy way to remember this is you just go directly across the top, like the numerators are multiplied, and then the denominators are multiplied. So for example, if you had 1/2 times 3/4, your answer would be 3 on the top, and then 2 times 4 is 8. Like your final answer would be 3/8. Okay, and let's go ahead and look at my last example. So here I have 2 dihybrids. So a dihybrid is an individual who is heterozygous for 2 traits. Di means 2, and hybrid is heterozygous. So here I have 2 dihybrids, and the question is, what is the probability of them having an offspring with blonde hair and no freckles? So we're asking, what's the probability of 2 dihybrids having an offspring that is homozygous recessive for both traits? So we do our Punnett squares. So here's for hair color, and I find there's a 1/4 chance that this couple will have a blonde-haired child. Then when I look at freckles, there's also a 1/4 chance this couple will have a child with no freckles. So what's the likelihood of both of these events occurring together? We take the 1/4 times 1/4, and then the probability of them both happening in the offspring is 1/16. Now, if you were to draw a big 16-box Punnett square, and you counted all 16 boxes, only one of them would be homozygous recessive for both traits. Probably the bottom right square. All right. Hope this was helpful, and great job.